Now in this video, let us consider another example. This time, instead of taking two concentric shells, let us take three concentric shells. Now, these are three concentric shells with their center at point C. Let these shells be A, B and C with the radius A, B and C. Let us give charges on them. First let us connect. You can connect. There are many combination of problems in which earthing is connected, sometimes connected to A, sometimes to B, sometimes to C. The process of solving this equation is same. So let us take, we connect B with the earth and we give charges, let us say Q1 on A and Q3 on C. Now when the B shell is connected to the earth, a charge of QE will flow and the charge acquired by the shell B will be QE. Now this is the condition after connecting it to the earth. Now this charge QE is coming on the B, so as the final potential should be equal to 0. This is the work of earth to make the potential equal to 0. Now if we calculate the total, what is the total potential on the shell B? Now total potential on the shell B will be due to Q1 charge on shell A, due to QE charge on itself and due to Q3 charge on the outermost shell C. So if we write the equation, then we will see that due to this charge K Q1 upon the distance from the center of shell B, because this is an inward charge. So what for this shell, this is for this inward shell, B is the outer charge. It is the this shell is inside B, so we can say whatever is the charge on shell B, whatever is the potential on shell B, the same potential will exist on all the points. Now what is the potential on shell B? Because of this, K into Q1 of A divided by the radius till shell B, so it will be B. So make no mistake here that the radius here will not be taken as A, it will be taken as B, because the shell A is inside shell B and it comes in the equipotential surface of the shell B. So this will be due to charge Q1 plus due to its own charge QE, it will have a potential KQE divided by its own radius, which is B. Now third is the charge Q3. Now for this shell, this is the outermost shell, every point inside the shell is an equipotential. So that means whatever is the point potential at this point, same potential will exist on this point. So what is the potential here? It is equal to K Q3 divided by the radius of this shell, which is equal to C. Now this is the equation, and by this condition this entire equation should be equal to 0. Now if we solve this, we can find out the value of QE, which is equal to minus of Q1 plus, this will be the value of QE. Okay, so this is how we can find out the charge required on the middle shell to make the potential of the system, or the make the potential of the shell equal to 0. Now if the question asks what is the potential, what is the final potential on each of the shell, that also we can find out. Potential on A, the innermost shell, will be because of its own charge, because of the charge on B and because of the charge on C. So because of its own charge, KQ1 divided by, now what will be the distance here? The distance will not be this radius, the distance will be because this is inside shell B, so whatever is the potential on shell B, it will have same potential on every point. So if we write here distance C B, then this potential will be same as the potential for A. So this is because of its own charge Q1. Now because of charge on B, which is QE, the potential will be KQE upon B. Now for C, every point inside C is at the same potential. So whatever the potential on C, every point inside will also have the same potential. So due to this charge KQ3, the potential at every point inside will be KQ3 upon C. So this will be the total potential on the innermost shell VA. Total potential on VB will be equal to 0 because it is earth. Total potential on C will be equal to all the charges that are inside it. So it will be K, and the overall charge Q1 plus QE plus its own charge Q3 divided by the distance from the center, which is its own radius C. Now some might get confused how this charge came. Q1 plus QE plus Q3. How does this shell has this entire charge on it? Now for this I would like to take you back to induction, the process of induction. Now see, if Q1 is the charge on this shell, on the innermost shell, then it will induce a minus Q1 charge on the inner surface of the shell B. Now since the electric field lines cannot penetrate the metal surface, so this minus Q1 charge will induce a plus Q1 charge on the outer surface of shell B. The outer surface of shell B already had QE. That means the total charge on the outer surface is now Q1 plus QE. Now this Q1 plus QE will induce an opposite charge here. So I'll write it here, which is equal to minus Q1 plus QE. This minus Q1 plus QE will induce an opposite charge on the outer surface, which will be equal to plus Q1 plus QE. This is the induced charge that is coming from the inside, but the outermost shell already had Q3 also, so that will be also added. So the final charge will be Q1 plus QE plus Q3. So this will be the final charge on the surface, and the same charge is written here. So this is how we come to this conclusion.